In this video, we're going to do a few more examples, including implicit differentiation. And we're going to begin with find the equation of the normal to the curve 3x squared plus 2y squared minus 14 equal to 0, where x equals to 2 and y bigger than 0. We know this question is going to need us to do implicit differentiation because the expression that we are given is not solved for y. So let's begin with the derivative. So derivative with respect to x of the function 3x squared plus 2y squared minus 14 would be equal to the derivative with respect to x of 0, and that is 0 as well. Now we can differentiate the left-hand side, and that's going to be 3 times 2x plus 4 times y dash minus the derivative of 14, which is 0, and then equals to 0. So we can rewrite this as 6x plus 4y dash equals to 0. Now the point that we are given is a point where x is equal to 2 and y is greater than 0. So when x is equal to 2, we can substitute in the original equation. So 3 times 2 squared plus 2y squared minus 14 equals to 0. And we're going to find the positive value of y. So that would be y squared is equal to 14 minus 12 divided by 2. That is, y is equal to plus or minus the square root of 1, and that is just 1. So because we need to take the positive answer, y is going to be equal to 1. So the point that we are looking at is going to be the point 2, 1. Now using this, we are going to go back to our derivative and we're going to substitute the point. So we're going to substitute 6 times 2 plus 4 times 1 times y dash equals to 0. And to find the slope of the tangent, we need to solve for y dash. So y dash is going to be minus 12 divided by 4, that is minus 3. The slope of the normal line is going to be the reciprocal negative of minus 3. So it's 1/3. And we also know that the normal line is going to go through the point 2, 1. So we're just going to substitute in the expression mx plus c and try to find the value of c. So 2 is equal to 1/3 times 1 plus c. c is equal to 2 minus 1/3. c is equal to 5/3. So our final answer is the equation of the normal line is 1/3 x plus 5/3. Our second example, a curve has the implicit equation y over x minus x squared over 8 minus ln y equals to 0. Again, we can tell that this equation is not solved for y, and also it has some non-linear components, for example, such as this one that is in y. Where y is bigger than 0, the curve passes through the point P where y is equal to 1. Show that x is equal to 2 at the point P. B, express dy over dx in terms of x and y. And C, find the equation of the tangent to the curve at the point P. So this question, although it's worded in a very different way, it's quite similar to the first example that we did. So to start with A, we need to find the value of x when we substitute y equals to 1 in the original expression. So I'm just going to copy the original expression here, y over x minus x squared over 8 minus ln of y equals to 0. Now, just a reminder that y is going to be positive. So let's substitute y equals to 1. We get 1 over x minus x squared over 8 minus ln of 1 is equal to 0. And we have to remember that ln of 1 is equal to 0. So this simplifies even further, and we write it like this. At this point, I would like to multiply everything by x to get rid of that x in the denominator. And I'm also going to multiply by 8 to get rid of the 8 in the denominator as well. So this is going to be 8 minus x power 3 equal to 0, which means x power 3 is equal to 8. X is equal to the cubic root of 8. And we know that that means x is equal to 2. Now we want to do b. We want to find the derivative of this expression, and we want it in terms of x and y. That means we just need to do the implicit differentiation and solve for y dash or for dy dx. I would like to use the product rule instead of the quotient rule, so I'm going to write the first term in a different way. I'm going to write it like yx power minus 1 instead of y over x, and everything else I'm just going to keep the same. And I'm going to differentiate this expression, y times minus 1 x power minus 2 plus y dash times x power minus 1 using the product rule on the first term. Now the second term is minus 2 over 8 x power 1, and the derivative of natural logarithm of y is going to be 1 over y times derivative with respect to x of y, and this is all equal to 0. I'm going to rewrite this and solve for dy over dx. So we find that the derivative with respect to x of y is equal to this fraction, and we don't really have to simplify anymore. We can leave it like that unless we see that it's going to be convenient later on. Now for c, we want to find the equation of the tangent at the point P. The coordinates are 2, 1. So we can find what the slope of the tangent line is going to be if we substitute in the expression for the derivative. So m, which is dy over dx, evaluated at x is equal to 2 and y is equal to 1, is going to be, so we find that the slope is minus 3 over 2. And now we substitute in the expression for y equals mx plus c to find c. So we're going to have 1 is equal to minus 3 by 2 times 2 plus c. Therefore, c is equal to 1 plus 3 equals to 4. The equation of the tangent to the curve at the point P is going to be minus 3 by 2 x plus 4. Our final example is find y dash if we are given x power 3 plus y power 3 equals 6xy. Then b, find the tangent to the volume of the card at the point 3, 3. C, at what points in the first quadrant is the tangent line horizontal? So the volume of the card, x power 3 plus y power 3 equals to 6x, is this curve that we have in pink. So we can tell that both the left-hand side and the right-hand side have expressions that combine y in a nonlinear way. So the only way we can find the derivative for this expression would be to use implicit differentiation. So let's do that, and we would have the derivative with respect to x of x power 3 plus y power 3 equals to the derivative with respect to x of 6xy. Next, I'm going to differentiate on both sides to the left is simple, is 3x power 2 plus 3y y dash, and to the right we need to use the product rule, taking 6x times y as the product. So this would be 6y plus 6x y dash. Now again we want to take all the terms with y dash to one side, so I'm going to move them to the left hand side and move everything else to the right hand side. So 3y minus 6x, common factor of y dash, is equal to 6y minus 3x squared. I do want to take the 3 out as common factor because I can see that I can cancel 3 from both sides. So that would get y minus 2x, common factor of y dash, is equal to 2y minus x squared. Now finally y dash will be equal to 2y minus x squared over y minus 2x. Now this would be the slope of the tangent, so we need to evaluate it at the point 3, 3. So y dash at the point 3, 3 is equal to 2 times 3 minus 3 squared over 3 minus 2 times 3. So we found that the slope y dash at the point 3, 3 is equal to minus 1. We want now to find the rest of the equation of the tangent line, so we substitute y equals minus x plus c, and we substitute the point 3, 3. So 3 is equal to minus 3 plus c, meaning c is equal to 6. Therefore, the equation is minus x plus 3. Now for c, at what point in the first quadrant is the tangent line horizontal? So looking at the graph, we can tell that there are 2 points where the tangent is horizontal. One being the origin, right here, the tangent line is horizontal, but also here. So our job is going to be to find the coordinates at this point, if you want x1, y1, and also this point, although from the graph we can predict that it's going to be 0, 0. So how do we find those? We need the slope to be horizontal. We need the slope to be equal to 0. So we are going to equate the derivative that we found to 0. So 2y minus x squared over y squared minus 2x should be equal to 0. That means 2y minus x squared should be equal to 0, multiplying the denominator to the right hand side. From here we get that x squared is going to be equal to 2y, and or y is going to be 1/2 of x squared. What does this mean? It's not a specific point. What is it? So we found that the points that satisfy the derivative being equal to 0 happen to be on the quadratic equation 1/2 of x squared. What that means is any point in this quadratic 1/2 x squared satisfies that equation, but not all the points in that quadratic are on the volume of the card. Only 2 of those points are in the volume. So to find these 2 points, we're going to treat the equations x power 3 plus y power 3 equals 6xy and y equals 1/2 of x squared as a system of 2 equations with 2 unknowns, meaning that I can use equation number 2 to substitute into equation number 1 and get an expression that is fully in x, and then try to find a solution for x. So that's what I'm going to do. I'm going to substitute equation 2 into equation 1. And doing that, I get x power 3 plus 1/8 x power 6 is equal to 3x power 3. This is the same as 1/8 x power 6 minus 2x power 3, and then I can factorize x power 3, common factor of 1/8 x power 3 minus 2 equal to 0. So here I get two options. The first option is going to be x power 3 has to be equal to 0. The second option is 1/8 of x power 3 minus 2 is equal to 0. From the first option, we get x equals to 0. And if we use equation 2, then that follows that y is going to be 0. So our prediction that the point x2, y2 was going to be 0, 0 is correct. Now, from the second option, we get x power 3 is equal to 2 times 8, that is 16. So x is going to be the cubic root of 16, and that is 2 root 2. And from here it follows that y is going to be 2 cubic root of 4. So we have found the two pairs. The first pair is 0, 0, and the second pair is the point 2 cubic root of 2 and 2 cubic root of 4. Now technically the point 0, 0 is not in the first quadrant, so our final answer would be this one.